then our last section is to determine which of the following electron configurations are not valid. Okay, so basically what not valid means is that it has an error or a mistake in it. Okay, so let's start with this first one. It says 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4d10, and 4p5. Okay, so the first thing I look for is the number of electrons. So we know that the s sublevel can hold a maximum of 2, our p's can hold a maximum of 6, d's can hold a maximum of 10, and f can hold a maximum of 14 electrons. Okay, so I like to make sure that none of these have too many electrons. Okay, so I check to see all of my s's have 2, all of my p's have 6, all of my d's have 10, so we're good on the number of electrons. Okay, so the second thing I would check for is the order of the energy levels. Okay, those are the big numbers right here. So I can check this by looking at my periodic table. So first we go through our 1s, and then our 2s, and then our 2p, and then our 3s, and then our 3p, so far so good, and then our 4s, and then remember our d starts with 3, so we should have 3d before we get into a 4p. So that is where the error. This should not be 4d10, that should be 3d10. Okay, so this one is not valid, okay, because there's a mistake in it, right? Second one says 1s2, 2s2, 2p6, 3s3, and 3d5. So right off the bat, I know that my s orbitals cannot hold more than 2 electrons. Okay, so this one is not valid because there are too many electrons in this s orbital. Okay, can't say 3, can hold a maximum of 2. Okay, next we have one that's in noble gas notation. So we have radium in brackets, and then it says 7s2, 5f8. Okay, so checking the number of electrons, those are a perfectly fine amount of electrons to fit in those orbitals. Checking the order, let's see, 7s is right here, and then I go into my 5f, so that is the correct order because it goes 7s to 5f. So my only thing left to look at is this right here. So we know that this in brackets needs to be a noble gas. Okay, and we find our noble gases in this right-hand column. So radium, Ra, is not a noble gas. It is actually an alkaline earth metal. Okay, so this one is not valid because that is not a noble gas. You can only use noble gases in these brackets. So this one is also not valid. Okay, number 19 says krypton in our brackets, and then 5s2, 4d10, 5p5. So first I'm going to check my number of electrons. S has 2, D has 10, P has 5. That's a perfectly good amount of electrons. Okay, I'm not going over these numbers. Next, I'm going to check the order. 5s2, and then I go into, remember this is 3, so this is 4d, 10, and then I go into my 5p5. Okay, so this is a perfectly acceptable order. So then let me check and make sure that this is a noble gas. So right here, krypton is a noble gas, and it is followed by 5s, just like how it's written. So I don't see any mistakes in this one. So this one is good. This one is valid. Okay, and then last but not least, we have xenon just in brackets by itself. Okay, so whenever we write the noble gas notation for a noble gas, you still want to use the noble gas that comes before it and do all of this notation, because just by looking at this electron or this noble gas electron configuration, we don't know anything about xenon. We don't know how many electrons it has, what its valence electrons look like at all. Okay, like this one right here, I can tell you that this element has 7 valence electrons. Okay, but I can't tell that about xenon because it's just in brackets by itself. So if we do the noble gas notation for a noble gas, you still would want to write it out like this. So xenon, the noble gas before it is krypton, so I'd write it Kr, and then I would continue with 5s2, then 4d10, and then 5p6, because now if I write xenon like this, I can tell you that xenon has 8 valence electrons. Okay, so this gives me valuable information that this does not. So xenon just in brackets by itself is not valid.